Find a Mobius transformation of the upper half plane. Upper half plane means the imaginary part of z is strictly greater than 0, right? Onto the interior mod w strictly less than 1. That is the interior of the unit circle mod w equal to 1, right? So we need to find a Mobius transformation for this. Suppose this is your z plane and this is your w plane, where this is your unit circle mod w equal to 1, right? They are saying that we have to find the Mobius transformation of the upper half of the plane, this, onto the interior of this unit circle, right? For that, we need to choose the points in the z-plane in such a way that when an observer moves through the point z1 to z3, passing through the point z2, then this upper half of the region will appear left to the observer, right? So the direction of the observer would be in this direction, so that the upper half of the region appears left to an observer. Similarly, we need to choose the point in the W plane that is on the circle. You may choose any of the points, but that should be chosen in such a way that when an observer moves from the point W1 to, let's say, W3, passing through the point, I'm taking this point as W2, then the interior of the circle appears left to an observer, right? So the direction of the observer would be like this, right? Anti-clockwise. So I'm choosing just the simple points. Let's say Z1 is -1, Z2 is 0, and Z3 is +1, right? Likewise, in the W plane, I'm choosing the points W1 to be as 1, and W2 as iota, and W3 as -1. So for these points, with the condition that the region lies to the left of an observer, then the desired Mobius transformation is given by W minus W1 divided by W1 minus W2, multiplying this with W2 minus W3 divided by W3 minus W, right? And this is equal to Z minus Z1 divided by Z1 minus Z2, multiplying this with Z2 minus Z3 divided by Z3 minus Z. The points are already mentioned here in the note, so we have to just put all these points over here now to get the desired Mobius transformation. So this implies, okay, W1 is 1, so this is W minus 1, then is 1 minus iota, multiplying this with iota plus 1, and then it is -1 minus W. This is equal to, please check very carefully, Z plus 1, then -1 minus 0, and then 0 minus 1, and then 1 minus Z. -1 minus 0 is -1, and this is also -1. So these two cancelled out. Let's manage the sign of this and this factor in the next step. So this can be written as W minus 1 divided by 1 minus iota into iota plus 1, and this becomes 1 plus W equal to Z plus 1 divided by, yes, this will be then Z minus 1 for 1 plus W, right? Okay, so this implies W minus 1 divided by W plus 1 into iota plus 1 divided by 1 minus iota. On rationalizing, we get 1 plus iota divided by 1 plus iota. So this is equal to Z plus 1 divided by Z minus 1. So this factor becomes, numerator is 1 plus iota whole square, right? So that will give you a square plus b square plus twice ab divided by, it is the formula for a minus b into a plus b in the denominator. So that becomes a square minus b square. So that is 1 square minus iota square. So this becomes, iota square is -1, so it is cancelled out with +1. So this is 2 iota divided by 1 minus -1, that is 2. So 2 cancelled out. So we get this to be as iota only, this factor, right? So this implies W minus 1 divided by W plus 1 into iota equal to Z plus 1 divided by Z minus 1. Taking this iota to the other side, taking this iota in the denominator, right? Now I'm going to apply the comparator and dividend rule. For that, I need to take the reciprocal of both the sides first, so that I have the positive part in the numerator. That doesn't matter. So to apply the rule for the numerator, just add the numerator and the denominator first. So this becomes w plus 1 plus w minus 1 divided by, for the denominator, subtract the denominator from the numerator. So w plus 1 minus w plus 1. Similarly on the right hand side also, adding the numerator and denominator and subtracting the denominator from the numerator. So this cancelled out and we get 2w divided by, this cancelled out, we get 2 over here. Taking z common, so we get iota plus 1 minus iota minus 1. Can I write like this? Yes? Okay. In the denominator again, take z common. So this is iota minus 1 and this becomes iota plus 1. Fine. So this 2 and 2 cancelled out. And also in the next step, I'm going to take this iota plus 1 common from the numerator and iota minus 1 common from the denominator, so that z remains alone. So w is equal to z minus iota minus 1 divided by iota plus 1 in the denominator, z minus iota plus 1 divided by iota minus 1. And also it is multiplied with, because we have taken iota plus 1 common from the numerator and iota minus 1 common from the denominator. So this is also multiplied with this. So this becomes z minus, okay, let's calculate these two separately. Iota minus 1 divided by iota plus 1. Rationalizing this, we get iota minus 1 divided by iota plus 1 into iota minus 1 divided by iota minus 1. So the numerator becomes iota minus 1 whole square. That gives negative 2 iota divided by 2. So this is equal to minus iota. And then solving for this, iota plus 1 divided by iota minus 1. So again rationalizing this, and we get iota plus 1 whole square in the numerator. So using the formula, we get this to be as 2 iota divided by 2, and this will gives us iota, right? So putting these values, so iota minus 1 over iota plus 1, this is minus iota, divided by z minus iota plus 1 over iota minus 1, this is iota, into iota plus 1 over iota minus 1, that is again the second one, this is iota. So this is equal to z plus iota divided by z minus iota, and this iota is multiplied over here, and this is equal to w. So this is your required Mobius transformation. Alright, thank you. Stay blessed.